All right. So how would you go about doing number 12? Well, I would just set this equal to an arbitrary letter like a. So 32 to the x equals 2 to the a power. 32 equals 2 to the fifth power raised to the x. So 2 to the 5x equals 2 to the a. What's a going to equal? That's how you show your work. That's how I want you to show your work. Yes. To an arbitrary letter. 100%. That's problem solving skills. Yes. That's exactly what I want. Play good.
For 11, since they're equal to A.
Sure. Yes. If I said equal to a, then it would be
Log base 30 both sides.
log base. I would do this. I switch it to log form. Log base 30 of a. You can move the exponent to the other side. And then a equals 4. I would do that.
Right, but it's just like a straight up property.
Yeah, pretty much. Yeah.
No, like 30 to the log 30, like we
Yeah,
know.
like something to the log of something of the same base.
Right, but just to show why it works.
Oh,
Yeah, that's yes, we know that, of course. But to be able to show that, or I mean, if I have something like this here, for example, an easier one would be what if I have a log base 30 of 30 to the x power? Then of course move the x to the front. That's using a property, right? Actually, that would be a better way of going about it, and that's x times 1. That's x. But I still want to see that. I don't want just running x. I need to see some work. Yep. What do you mean by equations? But any word problem, I'll give you the formula. 100%. Any word problem, you get the formula. Yeah, I'm not gonna. No, that's great. I'm not gonna make you memorize that. Yeah, you just have to know how to use it. Yeah, and I'll even do one better. I'll even tell you what all the variables represent too. Yes, I'll do that. Yes, I'm gonna get to that in a moment. Okay, any questions? Any other questions on the homework? No? Yeah, count good. Sure, let's do 10. Yeah, it's great. Yeah, for 10, I would write like this. I write natural log of e to negative 1 power. Then move negative 1 to the front. What's natural log of e, guys?
1.
Done. That's what I do. That's how I show you work. We're good on that one? Yes. Great question. And when I go over the test, I'll tell you what to expect. Actually, I'll just tell you guys right now. Expect a problem like, definitely expect a problem like number 3. Yeah, expect a problem like that. So we'll let a equal 4 to the x. So that would be 4 times a squared minus 5a minus 6 equals 0. Do you guys see how I switched that to a squared? Because think about it, isn't that 4 to the x then squared? Same thing, right? So that's why it's 4a squared. Then you can factor. I promise you my factoring will be much easier than this. This is a little challenging. What would that be? Yikes.
I think it's
Minus
like
a
a
plus
quarter or
one and
it's like
negative
2 and a quarter.
It's
2 and
24.
negative 3 fourths.
So 4a minus 1. No, that makes no sense. But so sorry, so
2 and negative 3.
2 and negative 3/4 is a minus 2 and 4a plus 3 then? I would agree. Good. Okay, thank you. Saved me some trouble there. Yeah, so if you factor, you get that. A equals negative 3/4. But you're not out of the woods yet. Because then 4 to the x has to equal each of those things, right? But can 4 to x equal negative 3/4? And what would the other one be? 1/2 power. 1/2 power. Yep, there we go. Yep. 2, how'd you go about 2? Yeah, multiply both sides by the denominator. And you have all this junk be multiplied by 200, right? Divide by 2 and you get 1/5. At this point, you guys should be pretty comfortable to do next. What do I do next after that?
Yeah, like subtract 1/5.
Yeah, so subtract 1 from both sides, you get negative 4/5.
Divide by
No, not yet. No. Please don't do that yet. Divide by negative 5, which would be 4/25.
Then
rewrite as a log equation. So negative 0.01x equals natural log of 4 over 25. And then divide by negative 0.01, you should get x. Yeah. That's what I do for that one. And actually, that answer wasn't displayed, right?
It's 22.2.
Okay. Yeah, go ahead. Emma?
Oh, wait, sorry, that's my.
Good, okay. Yep. All right, no worries. Sorry, it's a little messy because a lot of stuff going on in the print. Okay. Kind of good? Good on that? Okay. All right, so yes, Emma, go ahead, yes. No, don't be sorry, please. Go ahead. Yeah, I'll get there in a moment. But let's talk about anything on this first. Anything else? No? Okay. So let's finish off the notes. Let me just do just so we're clear on what the expectations are. I'm not going to do chapter 3 part 5 notes. That's logistic regression. That's like it's like a scatter plot or like best fit line stuff in your regression, but using exponential function or logistic functions. We're not going to do that. Or sorry, logarithmic function. Sorry, not logistic. There is logistic regression also. But yeah, we're not going to do that stuff. So I'm going to forego the last section. So 25 and 26, let's not worry about it. You can cross it off. But let's just look at the word problems on page 23, because I am going to have a word problem on the test. And it's going to be very close to one of the word problems we've done so far, or that we will talk about. So, or that's in the notes. So let's talk about earthquakes and talk about Newton's law of cooling, and then I'll talk about the test, and then you guys can use the rest of the class to do some work. And everyone has a packet, and everyone has review stuff. So if you look at this one here, Richter scale, that's what we use to measure earthquakes, right? I sub 0 is 1, great. I is the intensity of the earthquake, and R is the magnitude of the earthquake, the scale. So there was, oh, South Carolina, okay, that's weird. They had an earthquake 4.1. In Japan, they had a 6.5. Find the intensity of each. I think it's pretty straightforward, right? Just do 4.1 equals log base 10 of I over I sub 0, or just that, right? So I is going to equal 10 to the 4.1 power. I'll leave it like that for now. And for Japan, that'd be 6.5. And Livy, you said you tried to put this in the calculator, it didn't work for you. Okay, I'll when we do some review, when you guys are working on problems, I'll come by and look. Okay, so that's South Carolina, and that's Japan. So then I asked you to compare the two intensities. You want to divide Japan by South Carolina, because Japan's definitely more intense. And if I do that in the calculator, it's going to be at least 100 times more intense. Actually, we can subtract the exponents, right?
Yeah.
Wouldn't that be 10 to the 2.4 power? Which is definitely more than 100. It's actually 251. So you can see it's a pretty big deal, even though it's like, oh, we went up 2.4, it's not a big deal. That actually is a big deal. That's really scary to go from 4.1 to 6.5. Definitely gonna see some damage. So hopefully we don't have that here for a while. Yeah.
What's the point of like the I of 0 if it's gonna be 1?
That's just like the faintest earthquake you can feel. Because what if like because the Earth's always moving, right?
Yeah.
So like what if your intensity is 1, then your Richter scale is 0.
Okay.
Because you're doing log base 10 of 1, which I know is 0. But what if like the intensity is 10? So it's just a comparison. Actually, to be honest, I don't think it's really 1 ISO. I think it's like some smaller number.
Oh,
Yeah. It's like I don't know like how that's really what it really looks from a physics perspective. I should know this, but I don't. I forgot. Or maybe I don't know. All right, so let's look at another word problem here. This is a really good one. So you have some liquid that is at a certain temperature. So it starts at 212, and you'll serve it when it's down to 95 degrees. Okay. The room temperature is 75 degrees. And you hold it for 5 minutes, it goes down to 150. So how long do we have to sit before you can serve it to your customer? All right. So what do you think we're gonna do? It's a lot of information. What do you guys think? What was that?
Sorry.
Well, so first of all, what's TM? Yeah, that's the room temperature. That's so M stands for medium, like you know, the environment you're in. So that's 75. What's your initial temperature of the coffee? 212 because it's boiling, right? That's the boiling point for water. Okay, so we're gonna say 212 equals oh sorry, that I lied. We'll say T of T equals 75 plus 212. Sheesh. Minus 75 times E. Did I make a mistake?
Aren't you doing it for the ideal temperature?
No, how long is it gonna take?
Let's be patient. We'll get there. Let's wait. So now what do you think I should do next?
Like 150.
Yeah, so I have to use this information because I don't know what K is, right? I'm not going to do 95 just yet because I don't know what K is. So I have to use a given data point to solve for the constant, right?
Okay.
So because we know that T of 5 equals 150. Like maybe you measure that. Maybe you took a thermometer and a stopwatch and say, okay, you know, let's see what happens, right? It's kind of a neat little maybe second or third grade experiment if you want to. Maybe did a long time ago as a kid, but 150 equals 75 plus. And you said what was this guy? He says 137 E5K. So if you work it out, you should get this. So what's K gonna equal? Natural log of all over 5, right? What's K roughly equal to?
Oh yeah, send them like the homework to like make K and disaster value, but I don't know.
No, just use a decimal approximation.
The logarithm and the division to keep it exact.
You can.
That's like
That's which case in the argument.
Yeah, you can also store it too in your calculator. If you hit store and then a letter, you can do that too.
Oh, sure.
Okay. You totally could do that. Now, I'm not done yet because now you have to do this. And so now I'm going to replace the T of T with 95 and I'm going to solve for little t. And how would I solve for little t? Just kind of do all this junk here, right? Solve for t. Yeah, you should go at 16 minutes. Correct. You subtract 75 and divide by 137. Do not add 75 to 137, please. Don't dispute your order of operations. Please be careful there. Yeah. So does that make sense? That's an exponential type problem, involves some logs too. So yeah. Okay.
We can get a battle again.
Of course, yeah, of course. Y'all's good? All right, cool. All right. So now let me go ahead and clear. So now we're finished on the notes. Let's talk about what's on the test. Let's see here. His shoes are squeaking. Okay. What's on the test? All right. So I have right in front of me. Worked it out. Have the rubric done. I paced it. Like how many points? Yeah, exactly. I mean, not like an English rubric, like, you know, oh, like did you like the style or, you know, every discipline's different, right? Anyhow, yeah, it took me on under 10 minutes to do.
Really?
So you guys should be able to do it under 60 minutes, because my rule is like times 6, whatever long it takes me. I mean, I wrote the test, so
Yeah.
okay.
I wrote the test and saw the answer. It only took me 5 minutes.
Okay. But that's the pacing, right? Because
Maybe.
no, 'cause my rule I've calibrated. It's a times 6 rule. However long it takes me to take you guys times 6.
Okay.
That's been a hard and fast rule I've stuck with for 20 years.
What's the shortest it's ever taken you to do a test?
I don't remember. Yeah, I mean, but I wouldn't give a test. That would be a quiz then at that point.
You already know the answers.
I kind of suspect what they would be. So anyway, for part 1, expect 2 questions. And this will be non-calc. And this will be graph and calc. Expect 2 questions. One of the questions will be a log graph. And then it will be evaluate log / exponential expressions. Yep. There'll be 4 parts here. And the log graph will be worth 8 points. And this will be 3 points each. So it'll be 20 total points.
Are we just like graphing a log equation you give us?
Correct.
much?
Yes. Yes. And I would say it should take about 20 minutes. I think that's fair. To do a graph, you might need about 5, 6, I don't know, say 7, 8 minutes. I don't know. The expressions might need a minute or 2 per, I don't know. So depends how fast you work. But I think, but I expect most guys probably get done in about 15 minutes. I did this pretty fast. So anyway, yeah. So questions on that? What to expect? No? All right. And I'll also point to in the review pack I gave you guys, like which problems there's a lot there, like what you can focus on, like that makes sense. Because some may not be relevant, and I don't want you wasting your time and stuff. So I'm going to tell you what you can really focus on. Okay, so we're good there? All right, cool. Yeah. Yeah, exactly. Yep. It just here's the equation, just graph it. I mean, of course, I'll ask for the asymptote, domain range, all that stuff, right? Label your points, Okay. This one here is gonna have 6 questions. And they'll be worth 40 points. So naturally, it should take twice as long. So I say about 40 minutes. You might get it done sooner. I don't know. There'll be 4 solving equations. It could be log or exponential. So solving equations. Just straight up, here's an equation, just solve it. That's what I have you do. That will be worth a total of they have different point values for each of those. About 20 total points. So much worth 6, more worth 8 points. There'll definitely be a word problem. I'm not gonna say what kind. It could be earthquakes, could be what we just did right now, could be finance, could be half-life, pH. You'll get the formulas, yes. 1 word problem, and that'll be worth 8 points. And then there's a mystery question. Yeah, sorry, I was kind of holding my smile there. Mystery question, 4 points. So low stakes, but it's actually not that hard. It's like very, very doable. I just want to say what it is.
It's a Mr. E.
Exactly like that. I know. It's a play on words. Yeah. So that's 20 total.
Oh.
Yeah, the 20 total points. So like I think 2 of them are 6 points and 2 of them are 8 points. Okay. So that's the test. And actually, yeah, might be available on Zoom. Actually, I don't think I am. I don't think I'll be available. But I don't think you need it. Yeah, I won't be available, but I don't think you need it. So let me save this. Yeah, I'll show you the test from last year as well. So let me tell you what you should focus on in the review guide, and just to show you the format of last year's test. So last year's test, actually, I didn't like the format of it. I don't know if I really designed it well. So I copy and pasted from like I think during the pandemic, and obviously pandemic we're doing stuff online, so you're not using notes or homework. That's stupid. I don't know why I had that there. But the graphing a log equation is going to look very close to this. I'll post this school if you guys want. And I think at the end, it's going to look pretty close to this, like something kind of set up this way, where I would suggest you start with the parent function. Get the points for the parent function. And we do the parent function. What's the parent function? Log base 3 of the x. So x equals 3 to the y. Make a table for that. Then adjust that table for the transformation C in this equation.
Would pause method be like mandatory, like on the rubric getting points for that, or?
No. You don't have to do that way. But so the rubric would be this. Actually, great question. So I make this with 8, not 10 points. My rubric would be 1 point for the equation of the asymptote, 1 point for the domain, 1 point for the range, 1 point for drawing the asymptote, 1 point for drawing the graph, and then 3 points for labeling each point or stating what they are. So there's your 8 points. Here we had true or false. I'm not doing that because I already told you what I'm putting on the test. Well, actually, it could be the mystery. It's not the mystery question. I'll tell you right now. It's not the mystery question. But it's good to know. You should know your properties. So you should do this. It's good. So I will post this. Here are some equations. They look pretty close to this, actually. I did copy and paste this morning. And I just changed some things around. So they're gonna look pretty close to this. So I would practice these problems. This would be good. This had actually a little bit longer test. I think because we had longer periods. We had 75-minute periods back then. So I think this test is a little longer. So actually, I think that's why maybe one of our tests was too long, because I think I probably copied from 3 years ago. I didn't realize it was a 75-minute period. That could have been it. I don't know. Oh geez, this was pretty long. So anyway, we have like 3 word problems. We want a good taste of all these word problems. There's logistic growth one. There's a and finance one. There's the one we just did, Newton's law of cooling. So you get kind of a whole array of practice there. So but it'll look kind of like this, so the format, right? So
Wait, do we need graphic calculators?
you will need at least a scientific calculator. You don't need a graphic calculator. It's just nice. It's just the bigger screen,
Okay.
But we need scientific. 100%, yes. For the word problem, you do. You will not be able to get the correct answer.
Yes.
Yeah. I'd be really impressed if you could. In your head. You should work for NASA. Okay, anyway, really quickly, the classwork problems, what you should focus on. So here's what I just shared with you guys. To be honest, I think this first page is kind of, well, I don't know, they're good to do. I would say here, let me circle the ones I think are good for you guys to do. How about that? Instead of crossing stuff out. Let me stop sharing this. Here we go.
Thank you. I said it.
Oh, you're right. Yes. I'll do it again with the tech. All right. Okay. Okay. I would say you should, I know you guys can evaluate, so don't really waste your time doing that, but I think, solving is good. I like how you solve graphically. You're gonna have you use like logs. So I think that's good. 4, 5, 6. I think 7, 8 are good. Writing equations from a graph. Just to practice that skill. I think 9's good. Don't do 10. Don't do, yeah, just don't do those problems. Don't do 11. We're not doing those graphs. I already told you what graphs we have. Yeah, I think 12 is good. Maybe the mystery question. I don't know. Maybe. I like the way you asked that question. No, I know you didn't have that intent. I'm just teasing you. Maybe, I don't know, but I mean it's a good skill, right? So I don't know. There's a little, I don't have a good poker face. It's a little okay, it's not, it's not exponential modeling though. I'll tell you that right now. It's not, it could be something that involves, you'll see. It's not log either.
You know what? Natural. Oh, natural log. I figured it out.
You figured it out, yes. No, it's not that either. Anyways. All right, stop asking. It's a 13. Don't do 13. Don't do 14. Well, maybe I should change it now. No. I just worked it out, that's all. I have photocopied. All right. Yeah, I know. So much work. I'll give you another word problem. No, I'll throw some curveballs here. No, we're not sketching these, so don't worry about that. We're not sketching those. Let's see. Yeah, that's a good one. And that's a good one. Yep. 16, 17. Now don't waste your time with. Actually, 19's good because that might help with evaluating logs to be able to rearrange the bases. I think 19's good. 18, don't do. 19's good. I'm recording all this, by the way. Here, that entire page. You should do that entire page. All of it. Yeah, all of it. 27's good. I would do 27. No, don't do 28. Yes for 29, yes for 30, 100%. 29 and 30 is going to basically be like part 1 of the test. There's a graphing log and the value logs. 31. Yeah. 31, 32, I do. I miss Applewood Pizza. That was a good place. It's where Mount Mike's is right now. Applewood Pizza. Yeah, it's on the corner of El Camino and
Oh, yeah.
not Ravenswood. It changes names after you pass El Camino, but it's
It's
that
like-
corner.
Towards MN.
Yeah, 100%. Right. Anyway. Oh, yes. This is very good. More value. If you really want lots of value in logs, this is fantastic practice. This is really good stuff. Yep, I do 35. Yep. Now you should know the log properties, but I'm not going to ask to expand or condense straight up. It will just be baked into the equations, but you should know your properties. So I'm still going to suggest that you guys do these problems, so you know how that works. So you have 36, 37, 38, and 30 is a good one. Again, just practicing the properties of logs. Definitely like 40. I like 41. We're not doing true and false, but I would still do this. Yes. I would do all these here. Yeah, I do everything here. 46, we just did a problem like that. 47's a good one to do. And then here, I crossed off some on the ones I photocopied. But I do all these except for 51 and I think 53, yeah, because that involves, I think, future value. And I haven't gone over that formula with you guys, so it's a great formula to use, but yeah. 56, again, that's a Newton's law cooling one. 55 is good log problems. Ooh, that's a really good one.
That's a square.
Yeah. So, okay. And then I did post a homework assignment. I did say handout 12. You know what? Don't worry about it. If you want to do this for practice, go for it. I'm gonna remove that from school, so this won't be a homework assignment because we only got another 20 minutes or so. So yeah, it's okay. I'm not gonna assign any homework due on Thursday, but if you want more practice, this is still good. I would do all these problems too, and the answer keys are very close. So if you want more practice, go for it. This is really great to do as well. So yeah, because it doesn't really there's no regression problems here. So this is just more review stuff. So that's good. So you have plenty of, you have the pack I handed to you, homework 12. And yeah, I think that's it. All right.